My name is Eric Doudrick, and today I'm going to be talking about my paper on smart cities. This paper is intended to illustrate sort of the potential benefits of smart cities, as well as some of the pitfalls as nations sort of attempt to control their people as part of the overall apparatus of a smart city, um, and the dangers that sort of come along with the collection of bulk data and the processing of that data through AI systems. Generally speaking, a smart city is a city that uses sensors to metricize many of the inputs of standard city life, including city operations like simple as traffic lights and traffic patterns to quickly move people through their areas, down to the usage and supply of energy to sort of better control the flow of power in the most efficient manner possible. Smart systems also can dig into other kinds of systems in a city that will allow for citizens to sort of monitor their presence and monitor police activity and security with their devices, but we start to see the possibilities very early on of the pitfalls as people are tracked and targeted based on their presence or in alignment with certain events or structures or co-travelers that they may be traveling with who maybe come under scrutiny, and you very quickly can understand the Gestapo sort of nature of the smart city as this sort of bulk data and sort of maybe even AI-driven data aligns with simple nature of presence, and it's very easy for folks to get caught up in that just by simply being at the wrong place at the wrong time, skewing the data. In the end, the path to sustainable development through that, which is the second bullet there, is talking about being able to grow at an exponential rate, but still maintain the sort of level of access and utility that a citizen in a city, a smart city, would enjoy, and for the whole purpose of a smart city. That includes not having brownouts, and because of your social score, or being able to have enough power through future technologies to be able to sort of sustain that. Right now, China's dealing with, which I've talked about in the paper, sort of a hungry for coal. They're buying coal from all over the country, and they're opening more coal plants when the rest of the world is shutting it down in order to supply and support their energy to support these kinds of cities and their growing dependence on that kind of energy, even with a declining population. Intelligent infrastructure, like I said before, there are sensors that collect various types of information and metrics from all over the city in smart grids, again for efficient energy management. Internet of Things, which with the advent of IP version 6 and thousands and tens of thousands of IP addresses, it's literally possible to have an IP address for every article of clothing that ever existed in human existence. And so being able to use that addressing to carefully identify and stratify a human's sort of subdomain of possessions and interactions with a city really speaks towards the potential for a smart city, but also, again, the potential for that sort of complete loss of privacy. And I would say right now, with the advent of the smartphone and the sort of interactions with Google and Apple and the Siris of the world, that we're pretty close to that already. I think I read a statistic that showed that Google implemented an application that could identify, based on the changes in rhythm of your step, on whether or not you were a good candidate for a coffee, and suddenly you're beginning Starbucks ads in your phone and that sort of thing. And so it's just that nuance, that biomechanical interface with humans, sort of cities that create great opportunities and great understanding and absolutely unknown benefits from that kind of overlay of technology, but also the detriment of exposing that simply by being present and on that net. Key technologies, again, the Internet of Things is absolutely essential. Everything has its own presence, its own knowledge, its own understanding of its own place in that environment, and sort of how it interacts with all of the other organizations, when lights should change to support maybe pedestrian commuters versus traveling commuters, or for extended durations on crosswalks, or extended durations for vehicle light, for indicators for transportation, or perhaps for just to understand the uptick in certain medical structures that may indicate a problem in certain areas, and that sort of locality of problems that maybe cancer or sickness, to be able to identify situations like the COVID problems that we've had recently. AI is a very strong proponent, or a very strong component of this infrastructure. It's very important because the decision making and the sort of lack of human dissonance in thoughts, and dissonance in sort of perception, produce an opportunity for AI to remove the human element where we have cognitive dissonance when we choose certain things based on what we would like to see versus what the reality of it is. And so right now, sure, AI is great at sort of producing responses to questions quickly, producing code, but in the future, AI could very easily answer questions before they're even being asked, simply based on the metrics that are happening. And that's a very critical point, because some of those decisions being taken out of human hands might very quickly become threats to an American. If the system has enough autonomy, or creates enough autonomy, they become a threat to the human as a problem of efficiency, right? Our goal is to increase efficiency, and if humans become the least efficient part of that model, they become a risk to themselves. Some of those challenges occur, just like we're talking about. Intelligence services could easily bend and have, for instance, in the Hong Kong riots, have used artificial intelligence, facial recognition, human patterning based on the location of devices, and required our SIM structure that's in China, being able to track those things and understand where people are protesting, and then to be able to divide and conquer them based on that activity. It's very, very dangerous in a lot of ways for a human and a SIGINT structure to be able to understand and nullify certain pieces of data as red herrings, but then really quickly dig into insurgencies and threats to current government, whether or not that government is valid. And then simply talking about people who are not necessarily as independent physically, the disabled, and making sure that through this technology that they are being served in a manner that is directly proportionate to their need, right? It is pretty easy when you're dealing with metrics to consider all things being equal, right? We'll just replace this component. But if that component turns out to be a human, well, you have to deal with them as they come. And so being able to understand where these things relate to humans, and how those humans interact with the city, and sort of the social aspect of that is very important. And then folks who don't necessarily play by the rules. China's famously implemented this social score, where if you are late to work too many times, or you don't pay your library dues, or you're not a good Communist Party member, maybe you're not allowed to travel, and you have to pay more for train tickets, or you get you're last in line for certain amenities, or maybe food. Certain grocery stores in China, if you do not have a citizen chip on your device, it will literally not allow you to purchase food. And so we start to move into some that bottom layer of Maslow's hierarchy of needs, on whether or not you're going to get what you need, provided you're playing ball with the government. It's pretty scary, and very easy when most of our currency is digital. And so Very famously, we have these competing cities of Singapore and Beijing. Beijing is very, very focused on social control, as it happens in China. Very, very focused on social efficiency and social accountability, and Singapore's mainly based on building efficient infrastructure for their citizens to get to places and to be able to interact with the city in a more efficient manner. And so, as these two cities develop, it's very interesting to see how they collect their data, how they use their data, as I'm certain that the Singaporeans are using their data for law enforcement and intelligence just the same way that the Chinese are, but the implementation of that and the overt nature of that in Beijing is pretty evident and pretty obvious. And so success stories, I think, are just definitely the increase in efficiency in traffic. Traffic is a major limiter to success. If you're not able to move around your city properly because of the way it's being developed, or because of your dumb lights that only change it based on a timer, you'll find yourself with reduced efficiency. That's also seen in the energy sector, where we're able to see real improvements in the use and lack of waste of energy, where energy is supplied as it's needed, as opposed to sort of ubiquitously based on the resistance on the lines. And so that is definitely a major lesson learned for success, and we start to run into limits when it comes to utilities, to how far you can go with that. That doesn't overflow with the sort of human factor that's engaged with that. And so, on the other side of that, some lessons learned are just how exposed humans are with these technologies, and how vulnerable they can be to the collection of their metrics, and how connected those metrics are based on government implementation within devices that are purchased and put to market, and requirements that are based on the flow of data, especially within China and their Great Firewall. And so understanding sort of how to not be just reduced to a binary solution by your government, where you're welded inside your house during COVID, for instance. It's a good example of that. Simply based on data, we find ourselves needing to put great limitations on our AI structures. And so where do we go in the future? We have better communication structures. 5G is a ubiquitous communication structure. There's a lot of hype around whether or not it's harmful for humans from the electromagnetic interference perspective, but it's ubiquitous, right? It's sort of L-band for the people, that's able to sort of pass through lots of material, to be a ubiquitous and high bandwidth structures, so that as smartphones get smarter and have much more processing power, we're able to sort of be on all the time and pass that information in a way that sort of supplies and responds to in bulk the environment that device is put in. And you see the implementation of the next generation IP addressing, IP version 6, almost requiring that kind of bandwidth to manage that kind of the number of potentially communicating Internet of Things that would be associated with a person's sort of family or personal IP range as it's issued to them, right? And then how that structure is sort of implemented, and then protected potentially through blockchain technology. Blockchain technology, provided the originating source of that was as secure as as they say it is, one can be trusted that the data is tamper-proof for the most part. Although quantum technology puts that in question, although potentially quantum technology could then solve those solutions much faster and produce a more secure blockchain. It's really a race against time at that point, literally. And then which brings to bear the role of public-private partnerships, and sort of understanding the benefits and sort of the free market concept of data and metrics, and the implementation of efficiencies for profit and for sort of open access, and the danger of producing materials that limit that sort of free market, and to increase profit, or to limit freedoms. And finally, smart city, very dependent on those metrics. Those metrics are dependent on processing. The processing is dependent on communication structures. The communication structures are based on power grids and being able to supply power to all of these things, and the addressing required to sort of understand the differentiation between these devices as they're implemented into the grid. And then the dangers that are represented by understanding what the exposure of these metrics of people bring to the table, and how the nations may implement structures and elements in a peacetime or wartime, in a private or a public structure that infringes on people's rights, and the lack of oversight that may be created for some governments. That's it from me. Hope you enjoyed the paper. It's the third one I wrote because I lost it, but hopefully it's good. Thanks, bye.